Hello curious minds, and welcome back to our space lab.
In this video, we will learn what is infrared and how to use infrared to have its remote control properties to turn on and off a LED. Infrared is one of the spectrum of the electromagnetic frequency, just like light. But this does not fall in the visible spectrum, and that is why you cannot see it. But infrared exists all around us. The radio frequencies is a type of electromagnetic frequencies which cannot be seen. And similarly, infrared is also there. Infrared is used for smart sensorics and all the short-range communications which happen around your house to control Alexa, for example, and how Alexa controls the light. Let's see how we can start this project and what we need for it. We will need the microcontroller, the breadboard, the infrared sensor, an LED which we will control, and 7 connecting wires. Let's see how the connections are made. Connect the infrared sensor in such a way that the black bulb structure is facing towards you. In that way, the leftmost port is the sensor port, the middle one is the ground, and the right one is the positive port for the infrared sensor. Connect the infrared sensor to 5C, 6C, and 7C. Connect a white wire which is connected to the sensor port of the infrared to 5P and the other port to the 6 on the microcontroller, which is a pulse width modulation port. Connect a black wire from the middle port on the infrared sensor at 6B and connect the other end to the negative on the breadboard. Connect a red wire at 7B and insert the other end at 5 volt in the microcontroller. Connect the LED at 15C and 16C. Connect a red wire from 15B to port 7 on the microcontroller, which will be powering the LED. Connect a black wire from 16B on the breadboard to the negative on the breadboard. Connect a black wire from the negative of the breadboard to the ground in the microcontroller. Let's see how the program is written.
In this sketch, we'll learn how to use a library. No, not your local or school library to borrow books, but a software library. It is basically a reusable chunk of code that was written by someone else and can greatly simplify your life. In our case, the received infrared values have to be decoded so that we can understand them. And that is what the library will do for us. For our infrared remote control, we'll use the library IR remote. To install the library, go to the Libraries tab in your Arduino editor and then to Library Manager. There, search for IR remote. You can see that the listed libraries can be used in your sketch. Start the library you want to include in the sketch and then choose the necessary version. Here, we'll use the library version 2.2.3. When you do this, you'll see the library is now automatically included in the sketch. Then we define our variables. Here we'll need a variable for the infrared sensor pin. Let's take number 6. Then we'll need our helper from the library that will receive the infrared values. To create such a helper, we'll create a new object of a new type and call it receiver. It will receive the values from our sensor pin. Then we'll also need an object to store our decoded results. This is also handled by the library we've just installed. Such container for results is a decode results object in the library, and we'll call it results in our sketch. Now let's proceed to the setup. Here we'll want to observe the values that the receiver gets from the sensor and how they are translated by the library into numbers. So let's set up a serial monitor. Then enable our receiver object. This functionality comes with the library as well. In the main part, we first decode the received results with the help of the library. Here we'll write a simple if statement to make sure we have some results to work with. We will also use an ampersand and symbol to provide the decode function with an object that we have already created. The function will then use this object and store the decoded values there. Every time when a function uses a reference to an object, we need to use an ampersand. Then, in the body of the statement, we'll let the serial monitor print the results as decimal values. And then we'll let the receiver know that it can continue reading the next value. Now, let's start the program and try hitting some buttons on the remote control. Now, let's try pressing button 1 and read the value. Now, let's try pressing number 2 and read the value. Can you tell me what button 3 gives? And the button 4 and 5? This way, we can find out the codes for every button on our remote control and use them later in our sketch. Let's try controlling an LED remotely. We'll add another variable to the sketch, which will define the pin for an LED. Then we'll also define this pin as output in the setup part. And in the main loop, we'll add a couple of controlling if statements to turn the LED on and off. Let's say when we press button 1, the LED turns on. When we press button 2, the LED turns off. We'll use the codes for button 1 and 2 that we've just seen in our serial monitor. So if the sensor reads the value for button 1, turn the LED on, and if the sensor reads the value for button 2, turn the LED off. Let's see how it works. Yes, we can control the lights remotely. How would you use this in real life? Share with us in the comments below. Subscribe for the updates and hit the like button if the video was useful for you. See you in the next video.